Let it go and let it shrink. So I'm going to press minus to decrease the length of the muscle. You see it decreasing? Yes? So if I decrease the length of muscle, what is going to happen to force that muscle is going to generate? At this moment, which is the length of optimum, if I press S, it's going to create 10 units of force. Here. 1, 2, 3, 4, all the way to 10. Correct? So at this length, which is, I think is 19, 15, 16, 17, 18, 19, 20, 21. At the length of 21, we got the 10 units of force, correct? Yes? Length of 21, 10 units of force. Let's decrease the length. Let's decrease the length to, I don't know, 18 or 19. Then I'm going to press S again. The amount of force decreased. Why? Because remember the head of the actin and myosin, they are not in optimal length anymore, right? So we expect that it's going to increase the force. I'm going to decrease even more. Then it's going to decrease it. So this force is due to what? Tell me. Contraction. The head of the myosin is going to attach to what? Actin. Yes or no? Yes? So when you go below length of optimum, the force that you generate will be less. Is that clear so far? So let's go back and increase the length. So remember at that point, the amount of force was what? 10 maximum. Yes? So let's stretch it. Let's stretch it. Well, what do you expect? If I stretch it, of course I'm going to go beyond length of optimum, and still I have to create less force. Yes? Here we go. Is this coming down? Yes? So I can stretch it even more, but I want you to look at this dash. I want you to look at this dash. I want you to look at this dash and tell me, what is it? So I'm going to go back to length of optimum, right here. And I'm going to erase it, and then I'm going to press S. You see the dash over there? Yes? I'm going to stretch the muscle. Is that the dash went up? Yes? And then I'm going to press S to see it. How much force did I generate now?
No.
What's the length right now? Let's say 26 and a half, almost 27, yes? How much force did I create?
4 units.
How much force they create? What did you say?
4 units.
Basically, he's saying that from here to here, yes? Yes or no?
Yes.
He is partially correct. He's partially correct. Why? Because this force from here to here is due to what? Muscle contraction due to actin and myosin interaction, right? We call that one contraction or active tension. But when you stretch the muscle, we said inside the muscle like a rubber, you're going to be pulling the rubber, so you're creating what? Passive tension. And that is also tension. 1, 2, 3, 4, 5 passive tension. And let's say 1, 2, 3, 4 active tension. So the tension still is what? The total tension still is what? Is, let's say 8. The total tension. But majority is due to what? Passive tension. The rest is due to what? Active tension. Yes? So the total tension is the sum of passive tension and what? Active tension. If I ask you what's active tension, then your answer is 4. That is correct. If I ask you what's the total tension, 8. Probably 8. If I ask you passive tension, the answer is what? 5. Probably 5.
So doesn't it matter that they're going in different directions?
What do you mean? What do you mean?
Like the passive tension is opposite of the contractile direction?
Why do you think that make a difference?
Because sometimes when forces are in opposite directions, they cancel each other out.
That's a physics right there.
No, I want to add, we shrink the LO. We have the passive tension also. If we shrink the
Shrink? No, passive is due to stretching, like a rubber. If you shrink it, the rubber is not being stretched, so there's no passive tension, right? You got that? So very simple. So you increase it. Look at here. I'm going to increase the length all the way to whatever it is, 27.5. Look at here. What? The tension is the same. The tension still is 10. You see that? But all is because of what? Passive tension. The active tension is very tiny. See? So if I ask you what's the tension here, it still is 10. But 9.5 is due to passive tension. Probably half is due to active tension. You got that? You got to press Q and then you got to press 4 to leave this program. So this one is showing you, really showing you the idea of passive tension versus what? Active tension versus total tension.
What kind of questions are you going to ask us? Just like what part of this, what amount of tension is
Same thing, just ask you. I can give you this one and ask you what's the total tension, what's passive tension, what's active tension. You want me to tell you all the questions?
Yes.
Yes,
Give
please.
me a solid guy.
It's a piece of cake, really. You just checking your concept of understanding. It's very easy. Okay, so 1 and 2, forget it. Let's go to 3. Now, listen to me. This is the muscle. It's already in the optimal length. And the load that it's trying to pull is what? 3 pounds, let's say, whatever it is. The length of the muscle right now is what? 9 units. And the force obviously is 0, because there's nothing happening, correct? So I'm going to press S to stimulate this muscle and see what's going to happen here. Okay. It's a piece of cake. Look. When I stimulate the muscle, here's the stimulation, right? This is the force, right? When I stimulate the muscle is going to generate what? 1 unit of force? Yes? Or 1 pound? 2 pounds? But as you can see, the length of muscle is not changing. Why not? Because to move this one, I need how many pounds of force? 3 pounds. So, as you can see, 1 pound and 2 pounds, the length of muscle stays the same, correct? When you reach 3 pounds of the force, then muscle is going to get what? Shorter. Do you see that? So from here to here, we call what?
Passive.
It's not passive. Passive is when you stretch the muscle. I'm not stretching the muscle. It's called isometric contraction. Yes? So from here to here, isometric contraction. Then it's going to change to what? Isotonic, because the force stays what? The same, correct? You know what? Let's do it one more time. I want you to look at this box here. I want you to look at this box. Look at this box. This is what it says. Look at the box what it says. I'm going to see this muscle right now. Isotonic, yes? Before, did you see said isometric? Let's do it one more time. Okay, let's do one more time. I want you to take a look at this one. It says ready now, right? Isometric. Now isotonic. When it's isotonic, now the load is moving. You see that? But the rate stays the same. So now it's going to change back to isometric because the muscle is back to the same length. It's showing you basically isometric versus isotonic.
On the top graph, it's also isometric and isotonic. Isotonic is flat like that.
No, the flat one is the force. This, okay, listen, that's a good question. I bet you many of you has this problem. This part of the graph talks about what? The length. This part of the graph talks about what? Force. I cannot, listen to me very carefully.